Okay guys, so I'm going to talk about changes of state, and you should already know from your previous education that you have melting, evaporation, condensing and freezing or solidification. I'm not going to go through that, I'm going to go through the graph that you need to know about and understand. So here is the start of the graph. Now on the bottom axis we can have time, or that can also be, you could say, energy. Why time or energy? Because if I'm heating something, it's over a period of time. And as the time gets more and more, the energy that I'm putting into my substance is getting more and more, in this case, water. And here, guys, we've got the actual temperature of our liquid or water or substance or whatever. Okay? So I'm going to start the graph at the bottom here, and I'm going to pretend that this water here was an ice cube 20 minutes ago and I heated it up. Now what happened? The ice cube got warmer and warmer and warmer. Yeah? And if I was recording the temperature every so often, I would notice that at a certain point the temperature remains flat. Now that tells us something, and I'll come on to that in a second. It will remain flat, and then, in fact, let's go through it now. At this point here, this was the ice cube. Yeah? I put energy in, the temperature went up. Now here, the temperature of the ice started to flatten out. It didn't go up for a while. And at this point here, it started to change state. I would probably have half ice, half water in there now, and it might be somewhere between 0 and 4 degrees Celsius. And this flat line tells us a change in state. So right now, at this flat line, we have what we call melting going on. We might then get to the point where it's all water, and our water will start to rise in temperature, like this. In fact, like it's doing now, 75 degrees Celsius. So that's going to hopefully get to 100 soon. Now, as it's getting hotter and hotter and hotter, I'm putting more and more energy in. And it is a liquid, it's water here, isn't it? Now, what's going to happen here? It's going to flatten out again. At what temperature, you ask? 100 degrees Celsius, yeah? Boiling temperature. So here we have boiling. Again, a change of state. And here you're going to have rapid vaporization. A lot of your molecules are going to escape, and they're going to have more energy than the liquid itself. If you trapped all that gas, you'll find that the temperature is going to go well above 100, and it's going to be quite dangerous. So here now we have a gas. Alright, so what I want you to take home, guys, is that a flat line in a graph like this, a change of state graph, tells us that something is either melting or boiling or going the other way. Yeah? A flat line is a change of state. Why is it flat when it's changing state? Well, the energy that's being put into the substance is no longer going to the molecules per se, making them move more. It's going into breaking the molecules apart. And that's when they change the state. So you have the solid molecules tightly packed, and you put in the energy in, they're getting hotter and hotter, and then you get to a point where you're starting to break them. Yeah? And it's the same with a liquid to a gas. I hope that helps, and there we go, we've got boiling, it's going to stay at 100, and all of this gas here is going to be above 100. Check it.